Hi, welcome back. It's lesson number 2 on section 8.2 on distribution and factoring. Today we're learning how to factor using a greatest common factor. You might know that as a GCF. So the distributive property is definitely not new. We've practiced it in our class already, but there is a special relationship between distribution and factoring. And so it's important that we kind of cover them together so you kind of see that relationship happen. Okay, so let's get started. 8.2, let's start in that first one. It says find each product by using the distributive property. So I like to circle the front guy and then share it with the process of multiplication. So what is 7 times 8? 7 times 8 is 56x. What is 7 times 2? But negative 2, it's negative 14. If you got that, congratulations. Let's try the next one. This time we're sharing a number and a letter. So you've got to be more careful on this one. So 8 times 4 is 32. If you had an x and you got another x, we now have x squared. And 8 times 7, what is that? Again, 56, but minus 56, and here's the part that most kids forget, it's x. You brought 8x over to him to multiply. Let's see it to the side, 8x times 7. So it's 56x. So don't forget that x. Cool. Why don't you guys try 3, 4, 5, 6, 7, and 8 on your own? Because I know that this property is one you've used throughout middle school. So go ahead and hit pause and do the next 6 of the distributive process. Welcome back. How'd you do? Did you kill it? Let's see. So 2 times 3 is not 5. I know that's the pickle that I see most kids in. Remember, 2 times 3 is 6, and we have r squared because you had an r, he already had an r, now you have 2. So let's distribute that there, and that's 8r. Beautiful. Ooh, this one's definitely more technical, so be careful. We have 20. If you had 3 n's and they already had an n, it's going to be 4 n's. And anything times 1 is just that thing. Cool. Let's do the next ones. That's 21n squared plus 6n. Make sure it's 6, not 5. We are multiplying. We're finding the product. So 7 times 8. Well, if you didn't know what 7 times 8 was before, you now definitely know it because it's all over this worksheet for some reason. A3 plus 21a squared. Cool. Make sure you have that last variable. Common error. We have 24x cubed plus 21x, yes, squared. Great work. We have 64n plus, oh my gosh, 8 times 7 again, 56. Now why don't we have a variable at the end this time? I'll let you think about it. That's right, because we weren't sharing a variable. We were literally sharing a constant of 8. Easy breezy, lemon squeezy, super easy. So if you got those right, wonderful. Next section is factoring a polynomial. You can think of factoring as the undistributed process. We're undoing distribution. So this is the answer to one of these questions. So it's like me giving you this guy and saying, hey, what'd you start with? Think about that. If I gave you this, could you tell me what you started with? So factoring by a GCF is just the opposite of the distributive process. I like to think of it as division myself because I think that helps my brain to kind of understand the process by which I'm going through. So let's look at the first one, number 9. So the first thing I like to do is write a vinculum under each term. This is a binomial. There's 2 chunks, so write 2 vinculums, 2 fraction bar lines. Now, you have 2 things to look at. You have these coefficients in the front, and you have some variables. I like to focus on the numbers first. So 4 and 10. What is the largest number you can divide out equally. And I know if you're thinking 40, no, that's not what I'm asking. What number can you divide out of 4 and 10 equally? If you said 2, that is correctamundo. But we can also continue to take something else out. It looks like they have a variable in common. That means they share it. This guy has a single balloon. This guy has 3 balloons. What's the most I could equally take away from each group? Now, some kids would yell out, oh, take away 3. Really? Is that the most you can take from each group? Let's think about it. He has 3 balloons to give me. He has 1 balloon to give me. So the most I could equally take from each group is a single bee. Now let's actually put that. This 2b is called the GCF. It's the greatest common thing that I can take out of that binomial. So I put that GCF in the front. Look at how it's turning into a distribution question. Pretty cool, huh? Now let's divide. What's 4 divided by 2? 2. If you had 3 b's, but you took 1 away, how many do you have left? Yeah, if you said 2, great work. Plus, what's 5 divided by 2? I mean, shazam, dang it. What's 10 divided by 2? 5. I just ruined it. And if you had a b and you took a b, guess what? You ain't got no b. This is your answer. Doesn't it look like a distributive question? Let's check our answer. 2 times 2 is 4. A b and 2 more b's is 3 b's. 2 times 5 is 10, and a b brought, hey, that works. Let's try the next one. Next one is definitely easier. So let's put 2 vinculums, also known as fraction bar lines. We're looking for things that they have that we can take out that they have in common. Looks like they both have the number 4 in common. Do they have a variable in common? Do both terms have a letter? If you say yes, then we can take something out. If the answer is no, then we can't. They don't have a variable or a letter in common. And in this case, they don't have a letter in common. So the GCF is 4. 4 divided by 4 is 1. N minus 4 divided by 4 is 1. That is your answer. You could make that one invisible if you wanted because it's a coefficient, but this is a constant. He has to be there. In case you're like, oh, I'm going to forget, just put the 1 the whole time. And you can check your answer by the distributive process, and you get it. Let's try a couple more. Oh, this one's interesting. Number 11. It's kind of on the easy side because they don't have a variable in common, but they do have a number in common. Can you think of what number equally divides into both 12 and 15? Think about it. What smaller number, but it's the biggest, smallest number, can you divide out of 12 and 15? If you're like 5, well, 5 you can divide out of 15, but you can't divide 5 into 12. So it has to be something they have in common, a factor. And that is 3. They don't have a letter in common, so we're not going to take 1 out. So it's 3. 15 divided by 3 is 5. And 12 divided by 3 is 4. Cool. Let's do this next one. This one looks pretty easy breezy. They don't have a variable in common. They only have a single number in common. We can take that out front and determine what's left. So let's do 13 together and 14. Then I'm going to have you guys hit pause and you're going to try the last 6. Ooh, this one looks snazzy. Let's look at the 2 and the 3. Well, first of all, both of those are prime numbers. There's nothing you can take out of a 2 or a 3 other than a 1, which is just not very fun. So the only thing they have in common, it looks like, is letters. So if you have 4 of something and someone else has 3 of something, we have this one in common, this one, and this one. So they have 3 in common. So I'm going to take out 3. That's the most they have in common. So when you're looking at variables, you're looking at what's the most they have in common. So we're going to put an x squared in the front. That's a 2, x, because if you had 4 of something and you took away 3 of it, you'd have a single one, plus 3, because if you had 3 x's and you got rid of 3 x's, you ain't got no x's. And you could definitely check that using the You guessed it, the distributive property. Let's look at the next one. 4 and 3. Is there a number that we could equally divide out of both 4 and 3? Well, 1, but again, that's not going to do much, so they have no number in common other than 1, and you're welcome to take that out. How many letters do they have in common? He has 6 apples. He has 5 apples. How many apples do they have in common? What's the most you could take from each group equally? That would be 5. So we're going to take out 5 apples. We're going to put them in front, and let's check out what's left. Okay. Now what I'd like you to do is hit pause. Try the next 3 on your own. Go for it. You got it. Cool. Welcome back. How'd you do? Not too shabby? Let's check it out. Oh, this one's weird. It has a variable at the end versus the beginning. That's okay. It's just a different way to look at it. So what number do they have in common? What's the highest number that I can equally take out? If you said 2, boy, you're totally on the right track. But I think there's a bigger number, and that number happens to be 4. So remember, we're trying to find out the greatest common factor, the biggest thing that they have at the same time that we can remove. That happens to be a 4. They don't have a variable in common. Like he doesn't have R's, only he does. So that's not something they have in common, so I can't take it out. 12 divided by 4 is 3. 4 divided by 4 is 1. 1R. Or you could just say R. Next one. Ooh, this is my favorite. This one's a good one. We have letters. We have lots of things in common here. So let's see how you guys did. Okay. So it looks like they both have a 5 in common. And how much letter do they have in common? Well, this guy has 6, he has 5. Could I take out 6 from both? No, he only has 5 to give me. So the most letters they both have in common would be x to the 5th power. So we're going to take 5x to the 5th out front because that's our GCF. And we're going to see what's left. 5 divided by 5 is 1. If you had 6 x's, you removed 5. You're left with a single x. Remember that 1 is up to you if you like it. I like it. 25 divided by 5 is 5. And if you had 5 x's, you remove those 5 x's. There are no x's left. And you could definitely check that answer with the distributive process. And we have 4 more to go. And lesson number 2 is done. So the largest thing I can take out is a 4. They don't have a letter in common. So this is going to be 3 plus 5b. Let's check out this guy. The only thing that they have in common is a 2, and that's going to be 3n plus 2. This one, be careful. They got coefficients. We got some variables in there. What do you think? If you said 2, you're on the right track, but there's something bigger. What's that bigger thing? If you said 4, hot dog. Let's check it out. And what's the most variables you can remove? Well, they have 3 in common. So 4x cubed is my GCF. 4x minus 3 is what's left over. So my GCF goes out front, and my leftovers go on the inside of the parentheses. And we could check that using the distributive process. Ms. Miller, would you get those numbers again? Well, I looked at 16 and 12, and I asked myself, hey, what's the largest thing I can divide equally out of both? That's a 4. Then I looked at my variables. They have that in common. How much do they have in common? They have 3 in common. So I equally divide it out from both chunks, both terms, put that GCF out front, and then I determine what was left by the process of division. 16 divided by 4 is 4. I had 4 x's. I removed 3. I got a single x. 12 divided by 4 is 3. If you had 3 x's, you remove 3 x's, guess what? You ain't got no x's. And last but not least, question 20. 2, is it? It's not 4. You can't take 4 out of 10. It doesn't work that way. And we have 2n plus 5. Again, you can always double check your answers with the process of distribution if you'd like. Thank you so much for taking great notes. Make sure you print the homework or copy it down and turn it in. Remember this first week, just because, we're just trying out new things, Online distant learning is very much new concept for both you and I. So this first week we only have 2 assignments and they're due by next Monday. Please let me know if you have any questions, comments, concerns, good jokes. Love you guys. Talk to you later. Bye.